The last lesson in this module, vehicle level validation and flashing. So this is the last most important step, vehicle level validation and flashing. Now you may get a doubt, is vehicle level validation required? Because we are already going through mill, sill and hill. Yes, mill, sill and hill, it most of the time it eradicates or ensures that most of the bugs are eliminated. But vehicle level validation is really indispensable. Now, vehicle level validation is the final phase of diagnostic stem verification conducted on complete integrated vehicle rather than on individual ECUs or simulated environments if it ensures that diagnostic features work intended across all ECUs. All right. Now, communication buses, which include CAN, LIN, DOP interfaces under the real world scenarios. All right. Now, coming to objectives of the vehicle level diagnostic validation, ensure that DTCs, UDS, OBD services, security access, and data streaming behave correctly on the vehicle. All right. So, on the actual vehicle, whether it's behaving correctly or not, that is the main objective of doing this vehicle level validation. And validate the diagnostic trouble codes are properly triggered, stored, and cleared. Okay, so whether this is DTCs are properly triggered, cleared, that is checked on the actual DTC on the actual vehicle level. Now check the service tools communicate correctly with vehicles ECUs. Now test OBD readiness monitors and compliance with emissions regulations. Next is validate ECU communications, gateway functionality, and ensure that diagnostic services do not interfere with vehicle safety or performance. All right, so these are the various objectives which are tested on the actual vehicle. All right, so activities performed during vehicle level validation. This is a small tabular column. I request all of you to go through it. TTC validation is DTC validation, session and security testing, OBD mode validation, live data DID testing, actuator test validation, fault simulation behavior, gate network communication, performance tests. All right, so these are the various steps and these steps are clearly described here. I request all of you to go through these things very thoroughly. Now, now coming to example tools used, OEM diagnostic tester, ODIS for Volkswagen, ISTA for BMW. So these are the major tools used by OEMs like Volkswagen and BMW. Now, what is Vector Cano? Vector Cano CAPL scripting, Bosch KTS or generic OBD scanners, ETAS Inca for for measurement and flashing, real-time fault simulators. Okay, so these are the various tools which are used in the actual vehicle level validation. Now, what are the various compliance standard? Now, even at the vehicle level, even at the vehicle level, it is mandatory to ensure that these compliance standards are involved. ISO 14229 diagnostic service behavior, ISO 15031 SAE J1979 OBD mode compliance and emission data validation, EOBD EPA CARB vehicle level emission diagnostic validation, ISO 26262 functional safety validation during diagnostics, and OEM specific specifications, manufacturer validation test suits. Example, GM for General Motors GMW, for Volkswagen VAG, and BMW GS9500. These are the OEM specific specifications that are that need to be complied by before the vehicle is released into the market. Okay, now we will see one simple topic which needs to be covered at this particular context. What is ECU flashing? Okay, ECU flashing is the process of programming or updating the firmware, software, or ECU by writing binary data, hexagonal code S19, dot A to L, etc. into its memory, typically using diagnostic interface via protocols like UDS 0 by 34 to 0 by 36. Now, purpose of this flashing is install initial firmware in production, update ECUs during development or testing, rollout bug fixes, new features or updated diagnostics logic, and correct DTC behavior. All right. So correcting the DTC behavior also is the purpose of flashing, which includes UDS service enhancements and calibration data changes. All right. So these are the ways purpose for which the software or EC is flashed. Now let's see the flashing process step by step via UDS. All right. Now first step is start session, and the UDS service is 0 by 10. Here you switch ECU to programming session. Okay, in this session only the software can be flashed. So first you start the 0 by 10 session. Next you bypass or enter the security access by using 0 by 27. You authenticate using the seed key. Now what is meant by seed key I already explained in the previous lessons. Next, you disable communication write protection. Once you enter the security access, you disable the communication write protection by using 0 by 28 or 0 by 29 UDS service. And next, in this, you disable normal communication, enable memory writes, erase memory 0 by 31, erase flash area, transfer data 0 by 36, 0 by 37, transfer data blocks firmware hex image. All right. So here, this is the most important step. First you erase the memory, then you transfer the data by using this commands. Next, after transferring the data, you verify the checksum using 0 by 31 UDS command. But this is slightly optional because CRC check to ensure the data integrity. This is only optional to ensure the data integrity is intact or not. And next, again, you exit the programming by using 0 by 10. As you understand, both the start session and the exit programming have the same UDS services. All right. Reset ECU to default session or ECU perform reset 0 by 11. Now, when it comes to flashing protocols, the UDS on can these are the various protocols. When UDS on can ISO 15765 2 over the CAN, this is most majorly used for all ECUs. Next, when it comes to UDS on DOIP, Ethernet plus UDS. Okay, this is the transport layer, and high-speed flashing common in modern vehicles. Now, when it comes to KWP 2000, ISO 14230 still used in older vehicles for diagnostics. All right. So, and last but not least, the J2534, which is a pass-through protocol, and I already discussed about pass-through protocols in the previous lessons. And the transport layer is PC interface standard and standardized flashing via generic PC-based tools. So these are the various flashing process and flashing protocols which are a part of the vehicle testing. Understand this carefully. These are the part of the vehicle testing. Now we will see what are the various flash file types. What are the various types of files that are being flashed into the ECU? It may be a hex file, which is binary image of the hardware, or hex file, or .s119 or .a2l variable or measurement mappings for INCA, .odx diagnostic description used by ODIS, and .mdf measurement data file logging. Okay, now when it comes to flashing safety measures, security access, prevent unauthorized flashing, volt, and when you flash, these are all the various safety measures that need to be adhered to. First is the security access. Next is the voltage monitoring. Voltage monitoring means you should flash only when voltage is in the safe range of the for both battery and also the charger. Next is watchdog timer, reset ECU if flash fails or stalls. And when it comes to checksum validation, ECU correct firmware image, flash bootloader, dedicated firmware or managing secure flash operation. So when it comes to example, flashing the engine control unit, okay, first you connect the tool, which is the Cano or Inca, through the OBD port using J5234 or the OEM specific tool. Now, when it comes to ECU, it enters programming session. Tool sends 0 by 10, 0 by 02 programming session. And when it comes to authentication, seed key change to enable write access, erase and flash memory, data blocks transferred using 0 by 36, 0 by 37. And when it comes to ECU reset with 0 by 11 and switch back to default session. All right. So, and last but not the least, for post flash validation, which is of paramount importance. So in this step, you read the DTCs, run actuator tests, check the OBD mode compliance. All right. So hope all of you got a clear-cut idea how the software is flashed in a ECU when it comes in the entire vehicle perspective. Okay, what are the various steps? What are the various protocols? What are the various flash files? Okay, so these are all clearly mentioned in this particular lesson. So to summarize, we already spoke about the purpose, we spoke about the scope, we spoke about the environment. For example, environment is vehicle testing or garage or test track, and ECU flashing, lab, workshop, factory on remote update. Tools is OEM testers, Cano, Inca, OBD tools, flashing tools, OBD stack, J5234, and data over internet protocol. So standards follow are ISO 14229, SAE J19799, ISO 26262, UDS ISO 157652, ODX DOIP OEM specification. Okay, so hope all of you got a clear-cut idea about the vehicle testing and vehicle software flashing as far as diagnostics is concerned.